This section ties together energy and momentum, shows us how these two concepts are related via equations. And this right here is really the key equation for this section, that the E dx is equal to dpx dt. Now, you'll remember that dpx dt, this right here, is actually equal to F net x, so the x component of the force. So we're now seeing a tie between the energy and the momentum. We can also write this in terms of the finite differences as delta E over delta x is equal to delta px over delta t. These equations are the same, and they're really saying the same thing. So we're going to spend some time plotting E as a function of x. And so what this is really telling us is if we go ahead and have our energy plotted versus x, the slope of this graph is equal to the force. So knowing what the slope of this graph is gives us the force on the system. And so this is kind of a nice way of seeing how momentum and energy are tied together. It isn't terribly important that you follow the derivations in this section. The primary thing is that you come away with this idea here. One, that there's a relationship between the energy and the momentum, and two, well, actually, that connection actually ends up being the net force, and two, that you can find the force along a given direction from the slope of the energy versus position graph.